All right, good morning, everyone. Sorry we started a minute or two late. I was having some issues with OneDrive syncing. So today we'll be covering Chapter 4. So we actually have today and Thursday for Chapter 4. So if you look at the schedule, that's a good chunk of time. Plan to lecture for about 45 minutes, give or take. And then I'm going to have you all present the homework from Thursday's class. So I certainly look forward. I guess it was Tuesday's class, wasn't it? We didn't have class Thursday. But anyway, hope to see what you all decided to do for the table create statements. And we're going to continue working on those next class as well. Not the create statements, but certainly working on queries and that sort of stuff related to them. So with that out of the way, it's all about intermediate SQL today. Last class we covered the basics of SQL. So today we're just adding a few more things. Okay, so we're going to talk about join. We're going to talk about views. We're going to talk about transactions, cover integrity constraints, talk about indices, and lastly, authorization. So, the basics of a join. What a join statement is there to do is to allow you to get data from one table and compile it with other tables. So someone throw me a table. Customer. All right, so we got a customer table. All right, how can we select everything from the customer table? Select, star, and the important thing is from customer. All right, so we're telling it what we're selecting. What's the star mean? Everything, exactly. So all the columns inside the customer table from, we're saying customer. Okay, should be review, hopefully. Probably review from 223. I certainly cover a fair bit of SQL in 223. I'm not really sure what Paul does in his class. I don't think I had any of you for 223. That's a moot point, okay? So, what we could do, let's say, throw me a table related to customer. Sale. How about sale? I don't know what the relation is. I don't really care for this example. Okay? So what we can do is we can do a join. So we've selected star from customer. We could say join. And then, of course, it's going to be sale. And then just on. And all we have to do, take our first table name. So in this case, customer. And then period. And then whatever the primary key is for customer. Let's say cust ID. And let's come down here. And let's say equals sale. That's the second table. Dot cust ID. Okay? And by default, okay, what we're using is going to be the inner join. All right, so there's four primary types of joins we're going to discuss in here. Okay, you have the inner join. That's where you're taking the intersection, everything these two have in common. All right, so if for whatever reason, let's say there's a customer ID inside of the customer table, it's not inside the sale table, it's not going to be present inside of what's returned by this, because what type of join is it? It's an inner join. How do you know that? That is absolutely correct, okay? I didn't specify any type of join here. I left it at join. Ergo, inner join. All right? Don't get caught up in this left and right table stuff, okay? So really what we're saying is which table comes first? Okay, that's going to be table number 1. That's how I think about it. You know, I don't really know why I left this left and right. I just kind of did. But think about what comes first. Okay, that's going to be your left table. What comes second, that's going to be your right table. All right, so if you have a full join, what that's saying is that anything that is present in either table will be output. So let's say, for instance, I'm just going to fill this up with some random customer IDs. Let's just say 1, 3, 7, 9. Let's say over here we had 1 and 9. Okay, so in an inner join, we're going to have the records that relate to 1 and 9. Does that make sense? Is anyone confused? Because it's what they have in common, right? All right, so if we did a full join, all right, we'd have everything. So we would have 1, 3, 7, and 9. All right, and a left join, since a customer comes first, we'd have that as well. And then a right join, we would only have what sale had. So that's just going to be 1 and 9. Questions about joins? So again, just to review the syntax, select whatever you want to select. So in this example, we selected everything. We just use the asterisk symbol for the wildcard. But you're not required to do that. Okay? So let's say you want to select certain columns. So throw me some columns you think we may have in the customer table. Cust ID. What else? Okay, we'll just call it name. We'll just be simple. Phone. All right, now something in the sale column, or sale table, I mean. Column in the sale table. Quantity. Good enough for me. Okay, so what you can do is you can use select, and then you can put all these columns in there. However, I'm going to caution you and say that if you're ever doing a join, in this class especially, always put table name dot column inside of select. Okay, because that makes it a lot easier to know where stuff is coming from. If you don't do that and you have the same column and it's not acting as a key, that can cause a lot of problems. So just go ahead and do table name dot column whenever you're doing a join right here in the select statement. Does everyone understand that? All right, again, you tell it where you're getting it from, just like you would any other SQL statement. Put table 1, so your first table there. Join table 2 on setting the primary keys equal to each other. What did I forget? What goes at the end of a SQL statement? Semicolon. I forgot a semicolon. Huh. Wonder why this thing's frozen. Anyone know? That's weird. Huh. I don't think there's any options on this thing. Just look at this one. I didn't even know this was frozen. Yeah. Forgot to talk about the tips. So specify the type of join before join. Again, if you want to leave it at inner join, you don't have to. But we could stick right here. Okay? We could also put left here. Okay? What's another type of join we could stick here? We could certainly stick full here if we were so inclined. And if we wanted to, there's absolutely no reason to do this. We could also put inner here. All right, who remembers why there's no reason to do that? Because the default is inner. Specifying the default. That'd be a waste of breath. All right, talk about table name dot column. Okay, that's very important. It'll technically work in most cases without doing it. But, do you want to be sitting there troubleshooting a problem? Okay, you probably don't. I don't. So I would say always do that. All right, you can also nest these. Okay, you don't have to have 2 tables. So basically, you can continually do joins, and you can just keep doing them all day. If you have 5 tables, you want to join them all together, that's certainly within the realm of possibilities. All right, questions about joins? Let's talk about views. So what views are is they're predefined, almost like a predefined SQL select statement. And there's a couple advantages here. Somewhat advantageous for security, although certainly don't rely on them for your database security. But they're part of the picture. Because the idea is, you give someone a predefined view, you say you can access these specific views, they can't pull down all the social security numbers. They can't pull down home addresses, so they can access limited information. It's also easier to use, when I'm teaching 223, okay, believe you me. Let me mute this real fast. So if you're using views with select statements, they don't have to understand it. Does that make sense? Okay, so you create a view instead. All right, it also has reduced errors. Not a huge advantage there, because a select statement, for the most part, you're not modifying any data. Okay, it's technically possible within a select statement if you were doing like select into, but for the most part, when you're doing a select statement, you're not modifying data. So errors, in my opinion, are not really as big of a concern. Now, when you're inserting into, we'll talk about how we can sort of mitigate a lot of those problems. All right, so to create a view, just like you create anything else in SQL, okay, use the create function. You're going to create a view. So before, we've done create what? Table, okay? So it's the same exact syntax, okay? SQL has some of the easiest syntax of anything, okay? It's not a programming language, but it's parallel to them in some extent. So, you're creating a view. Call the view whatever you want. And then and then you have your SQL select statement. So if I wanted to, let's say I wanted to come over here, and I want to just do create. I might as well turn this off, if it's not even going to be working. Okay, so I can just come over here, do create view. Someone throw me a name. What should I call this view? About custom sale. And then just say as, and then you have your standard select statement. That's what we're doing. Okay, pretty straightforward. Questions about views? So you name the view right after you say create view. You can call it whatever you want. Best practice to make it something that's meaningful. But yeah, you have a lot of flexibility with that. Yeah, so that's how you're going to use it. You just sort of call it back into play once you've created it. So this is not storing any data, okay? The data is still stored in the table. But what this does, this allows you to then reference the query without typing the whole query over and over. And also, we're going to talk about authorization in the next couple slides. I think it's around slide 14 or 15. Don't quote me on that. But the idea is that you can provide authorization to certain users, or better yet, certain groups. And the authorization could include that they're allowed to view this view. They're allowed to use the view. That's probably a better way to say it. All right, so you can easily modify views, same exact way you would with SQL. Just use your standard functions. You know how you do that, of course, we've talked about. So same exact stuff there. All right, transactions. So what a transaction is, in the context of this, is a sequence of queries or updates, or some sequence of operations, I would say. So let's say you're a database administrator. And let's say you're tasked with, I don't know, taking a list of users and removing them from a database. So you could put that into a transaction. Okay, you run the transaction. When you run it, of course, it's going to be commit work. Okay, if you realize you made a mistake, you could roll it back. Okay, that's called rollback work. And this is all done through scripting. Okay, So basically, you think about when you're inside of, in this class, PostgreSQL, you're making scripts. Okay? That's how you do everything. Okay? So what you do is, if you're running a little bit at a little bit, it's not necessarily a transaction. But if you make a script and then you run the entire thing, that's a transaction. All right, does that make sense? And, a lot of times when we're talking about scripting, we don't have to be scripting within SQL. Okay? Can other programming languages interface with SQL? Yes. All right, how many of you guys have taken Ivan's class? Okay, some of you. So let's talk with Ivan before class. You guys are using Python in there, right? So R and Python. Okay, both of those can interface with SQL databases. Pretty cool, huh? All right, so there's a lot of stuff that you can do with standard SQL queries, but there's even more stuff you can do using the interfaces from other languages. Does that make sense? All right, because let's face it, you have a very limited number of functions and operators inside of SQL, no matter which SQL implementation. You don't have any limitation. Well, I wouldn't say any. There's very few limitations in programming languages, though, right? So a little bit beyond this class, especially for intermediate SQL, but just understand that a lot of times you'll find it's not only easier to use programming languages, but it's also quicker. So I'll give you an example, okay? When I was doing my dissertation, all right, one of the tasks I had was I had to get 15 million observations. Not 15 million, data points, 15 million records in total. So you're talking about hundreds of millions of observations, all right? So 15 million records. So each record had about 900 columns. You know how slow it was in PostgreSQL? Ridiculously slow, all right? So you know what I did? I imported it with Python, and I was able to do that in a couple minutes, whereas it's going to take, multiple days with PostgreSQL. PostgreSQL is much faster than many other SQL implementations, but it's still slow when you have that many records. Does that make sense? And also, that many columns doesn't help either. So a couple slides, we're going to talk about indices and how we may mitigate a lot of the problems with slowness, but you don't have an index until you've imported the data. All right, integrity constraints. All right, data consistency. That's what this is all about here. Okay, so if we are inputting data, we want to make sure that it has integrity. What does that mean? Does that mean it's good, honest data? Data doesn't do anything wrong? We're not going to have to send the sheriff in to arrest our data, are we? Okay. Is that what we're talking about with data integrity? Why not? What are we talking about? Exactly. So we're making sure the data is correct. Think back to your security class. Everyone in here is enrolled in security. What are the 3 primary goals of information security? Exactly right. Integrity is vital to data. All right? If we have incorrect data, does it provide us with value? Let me rephrase that. If we have data with a substantial number of random error, so you guys understand the difference between random and systematic error, right? What is random error? What is it? Okay, so random error is error that is done in a fashion that can't be undone. So let's just say that I have a data set, and let's say these are the actual true values. Okay? So random error is going to be like taking a random multiplier. You guys have used rand before, I'm sure. Maybe in Excel, maybe in other classes, other languages, that sort of thing. Think about taking a random number. All right, so I'm just going to put some random numbers on the board here. All right. Is there any approach you can take to go from your bad data to your accurate data? Is there anything? Okay, there's nothing. Now let's say that I, instead of doing random error, had systematic error. So systematic error, as the name systematic would imply, is where you have error that is undoable because it follows a structure. So the structure could be addition or subtraction. All right? So I don't mean to fuss, but are you guys taking notes? If you don't know the content, like I said, take notes however you want, but this kind of stuff, well, there are no exams in here, are there? I was going to say this kind of stuff could show up on an exam. I played myself, didn't I? How about that? But still know it, okay? All right, so systematic error, either a plus or minus, or in some cases it could be a multiplication by a constant or a division by a constant. So let's say that we had systematic error where we take plus 10. So 37, 101, 82, and 71. Okay, that's systematic error. If you have this and you know what the error is, can you go from this to this? How? So if you're adding 10, you subtract 10, you're at the real data. All right, let's use another example of systematic. Say we're multiplying by a constant that's not 0. Okay, well, why can't we multiply by my hero 0? All right, because if you have everything as 0, you don't know if it's 27, 91, you don't know what it is, But for any other constant, say we had multiplied by 2. So 27 times 2 is 64, I think. 91, oh boy, I didn't think this through. 182, 72, 146, and 61 is going to be 122. Can you go from this to this? How? Divide by 2, exactly. All right, so that's random error versus systematic error. All right, how did I get off on that tangent? What was I talking about before? Integrity. I don't remember how I was going to relate that, but the idea is that you want to avoid random error. Okay, some of the stuff we can do to avoid random error is have data constraints in place. Okay, validation checks. All right, so some of these that we may face, not null. Okay, you literally just put not null after the data type. That's how all these work, by the way. All right, so if we were defining a new column, let's just say we were saying, I don't know, someone throw me your favorite column. Someone throw me your favorite column. Any column. Name. We'll call it first name. All right, so first name, it's going to be a varchar. Let's call it 15, and say not null. Whoops, not a semicolon, just a comma. All right, what that's doing is that's saying once you insert into whatever table first name belongs to, you cannot leave first name null. Okay, so who remembers what null means? Talked about it last class. Missing, no value. All right, so a couple different ways to express it. A wrong way to express it would be a 0. Okay, a 0 is not missing. Some people treat it as missing, but they're wrong because 0 is a value, is it not? If you have 0 of something, you have a known quantity. It just happens to be nothing. Okay? So imagine someone were to throw a marker across the room, all right, I don't have a marker anymore, do I? I have 0 markers. It's not that I don't know how many markers I have, I just don't have any, all right? But, if I were to pick it back up, I have how many markers? 1, okay? So 0 is not a missing value. Some data sets may treat it as such, and if they do, that's a problem. All right, because like I was saying, if you multiply everything by 0, you can't go back, okay? You take 27, multiply it by 0, what do you get? 0. Take 72, multiply it by 0, what do you get? 0, okay? So be careful about 0. All right, unique. So in some cases, it may make sense to have values be unique. Now you may be thinking, well, primary keys are certainly something that should be unique, and you're correct. However, you don't have to specify not null or unique on a primary key. It's implied by the definition. So what are some other things we may think are unique? Let's say social security number. Should it be unique within a database? In some cases. So if you're inside of a customer table, and you have it defined where customer, an entity or an instance rather of customer is an actual customer, then you shouldn't have the same customer in there multiple times, correct? So in that context, should you use social security number as a primary key? I would argue you should not, but if you're having to collect primary key, you could apply the unique modifier to it, and then you could certainly use it and have it be unique. Now, that's obviously not foolproof, okay? You got 350 million people, give or take, in the country, all right? So if you have you have a billion possible social security numbers, roughly. Okay, technically that's not true, but roughly, all right? That's a pretty substantial number. If you just throw a random number at the wall, it's probably someone's social, right? If they're not currently living, is it probably someone dead's social? Yeah, probably. So that's how you would use unique. Any questions about it? All right, check. So check is a little bit different. And what it does is you assign it after the definition. So instead of having not null, we could have a check. I shouldn't say instead of. You could have it in addition to as well. I just don't have space on the board. All right, so you have your check, and what this is going to do, it's going to verify that whatever we're doing is inside of a predefined list. So, for instance, you could use this syntax up here, where you have the list inside of the particular create statement. Or, yeah, create statement is correct. Because all this goes inside of a create table statement, right? All right, so what you would do is you would literally type in all this. So check whatever column. In this case, it's going to be, of course, fname. And then you say in, and then list off all your items there. All right. That's a pretty messy way of doing things, is it not? Why is it messy? Could take forever. That's certainly one approach. What other problems does that have? Okay, so you're manually typing everything. Works fine for stuff like quarters, even for stuff like months. Okay, the book is an example of seasons. Personally, I'm not a big fan of seasons. I prefer quarters. Maybe you prefer seasons. That's not really what we're talking about here. What if, instead of doing that, you wanted to do days of the year? All right, you want to make sure you don't have. Have you guys seen the stuff online where people post like milk that expires on February 30th? Do you guys know what I'm talking about? That could be done in a check, could it not? Easily. All right, there is never a February 30th in whatever calendar system we use. I don't remember what it's called. Doesn't matter what it's called, actually. Okay, just imagine you're doing a check and you're manually typing 365 days. Who wants to do that? Check out this little cool emoji. All right, what's that mean? Cool way to do it. Exactly right. Okay, so a much better approach is to have a column somewhere in the database that contains the days of the year, or that contains whatever you're wanting to do. All right, it doesn't even have to be in the same table. You could do table.column if you wanted. All right. What you're doing, though, is that you're checking that your column that you're interested in, so in this case, first name, well, that wouldn't really make sense to do, would it? Okay, but let's say it was a column that made sense to do a check on. Let's say prices. Okay, so if we had price inside of a sale table, for instance, all right, we want to make sure that the price is present inside of an inventory table. So that way we're not just assigning random prices. We're assigning a price that is in fact correct. All right, so you can certainly do that as a check where you have it reference the inventory.price. Does that make sense? So that would go inside this column part right here. All right, questions? Like I said, this way is not wrong. It's just for more than a handful of items, you're wasting your time. No need to waste time. Referential integrity. In fact, wasting time is actually a very bad thing. All right, you think about it from a business perspective, which is the perspective we should be thinking about things from. All right, if you're wasting time, what are you doing? You're losing money, okay? So if you're a business owner and you have employees wasting time, you should be unhappy, all right? You should find ways to not waste time, all right? I always thought it was kind of silly, the idea of business work, or busy work, I mean. You know how many times I've ever assigned busy work? None. All right, I don't do busy work. So, referential integrity. Some more things we can do with it. All right, you can say references. All right, what that's going to do is very similar to a check, where you're referencing some existing column. And the good thing about this is we can actually defer this until after the completion of an entire script, if we desired. So there are certainly some cases in which having those referential integrity constraints may make sense, but they may not make sense until all the data is input. Then we perform the check. That could make sense in some cases. All right, what we're doing in this is mostly going to be for foreign keys. All right, so we're referencing some other column in some other table. That's the whole definition of a foreign key, in fact. All right, it's referencing some. In most cases, it's going to be what? It's going to be what in most cases. So what is it referencing in most cases? Most cases, it's going to be a primary key. Not every case, though, right? It can reference candidate keys, no problem. All right, it can reference anything, no problem. But most of the time, we think about it as being a primary key. And why do we do that? What's the point of a foreign key? It's on the board. So you're joining tables. All right, if you don't have a join condition that they have in common, how are you going to join them? You're not. All right? So that's the point of a foreign key. Does everyone understand that? All right. So let's say you have an ID variable, and for whatever reason, it's a number, but it's stored as a varchar. So this is something that may take place, hopefully not if you created the database yourself, but let's say you inherited a database that has some minor issues. All right, so we can actually convert inside of SQL pretty easily. All right, so all we're doing here is we're converting one data type to a different data type. And a couple of different ways we could do this. Okay, so the first way is whenever we use a cast. So when we're casting something, we're not actually converting it. Okay, what we're doing instead is we're temporarily converting it for the purposes of a select statement query. All right, so what you do is you say select, cast, and then whatever column you're wanting to cast, then you use the as modifier, and then say whatever data type you're wanting to cast it as, and then you cast that using as whatever you want to call that column. And what this allows you to do is, the example from the book at least, is you're taking the column that's like acting as a varchar, you're making it into a numeric thing, so that way you can sort the numeric thing numerically. Does that make sense? Now, this is useful for select statements, but you're not actually changing the data. If you want to change the data, here's how you do it. All right. In MySQL, which I personally am not a big fan of MySQL, all right, what you're going to use is the format. Okay, so you're going to use format and then whatever format you want to format it to. All right, pSQL, what we're using in here, obviously, and also a lot of Oracle databases. So MySQL, of course, is, I don't know if the term is owned for open source, but what is the term for that? Well, let's just say Oracle owns MySQL. I think that's a simplification. You start getting into open source projects, it's difficult. But the idea is that Oracle and pSQL share a lot of these functions. All right. So if you had something that you wanted to convert to a character, all right, use to _char. Okay, you have a character, you have a varchar, some sort of text. You want to convert it to number, to _number. All right. Let's say you want to convert a number to a date, or characters to a date, to _date. Pretty straightforward. All right. And then SQL Server does things a little bit differently as well. All right, use convert. All right. So those are the three primary different ways. You guys remember how I said that the MySQL implementation, or the SQL implementations, are going to be mostly the same, about 95% the same. This is the 5% differences right here. Does that make sense? So, let's say that you're working on a project, and let's say you forget some of the SQL syntax. Where can you go? Okay, you can go to W3 Schools. All right, they have a great tutorial, really simple to use. Pull it up, take a look at it. All right. So, default values. If you want to assign a default value to a column, you can certainly do that pretty easily. So inside the create statement, basically after the data type, you're going to put default, and then notice have value in italics. What does that mean? It means you put in whatever the default value you want to have. So if you're using salary, maybe your company has a base salary. Let's say your company's base salary is $50,000. All right. So you're creating the salary column. So you call it salary. That's probably going to be a double. All right, and then you say default. All right, and we said 50,000, right? That's what you're doing. So, like I said, most of these modifiers, referential integrity, all that stuff, it goes after what? What does it go after? Data type, exactly right, okay? So if you have data type is double, put it after double. Data type is varchar, put it after varchar. All right, indices. This is an important topic when you start getting into big databases, all right? And let's face it, if you go off and you get a job that deals with databases, and you're at a company of any size, is it going to be a small database or a big database? Probably a big database. So like I was talking about with my 15 million records, that's not big relative to database. That was a couple gigabytes, all right? That's not big, okay? We're talking about big, we're talking about multiple terabytes, all right? That's larger than the average, certainly, but not big, all right? So what an index allows us to do is to sort of predefine stuff to help it produce the queries. And we're going to talk a lot more about indices in some of the coming chapters. I think that's, who's got the schedule pulled up? What chapter do we talk about indices in? So if I'm not mistaken, we spend 2 chapters talking about indices. 14. And then there also like an advanced indices or something? 24. Isn't it kind of crazy how the, well, let me all right. So we're going to talk a lot more about this, but just understand that it speeds up processing. So if you have hundreds of millions of records, first of all, it probably shouldn't be inside a relational database. Why not? It's going to be very slow. All right, like I was talking about. You know, P-SQL is fast compared to MySQL, but it's still slow compared to non-relational databases for that number of records. So if you have a database that's constantly having updates, constantly having queries, probably doesn't make sense to be relational. It could, but it doesn't necessarily. All right. So the general syntax, like I say, you're creating something. So use the create function. Create, telling you what you're creating, an index, call it whatever you want. And two different ways to do this. You could just say the relation name if you want to create an index between tables. Or, of course, you could also say for a specific table, primary key specified. So this is a simplification. Like I say, it's multiple chapters in the book. Okay, so right now, we're just saying what it is and why it's used, but we're going to go a lot more into it in the coming weeks. All right. Authorization. This is an important topic because, you know, data should be used throughout the organization. And we want to remove information silos in most cases. All right. What's an information silo? So not exactly. So you're thinking of an enterprise data warehouse. So an enterprise data warehouse is a large database containing information central to the organization that's shared throughout the organization. And I'm going to call this EDW. All right. And you have different things interfacing with it. So you have like an ERP. Okay. You have like a TPS. All right. And lots of other stuff interfacing with the enterprise data warehouse. And the idea is that, number one, this structure provides data independence. We're talking about data independence. What that means is that if you get mad at your ERP provider, you can just remove the ERP, replace it with something else, and it's still interfacing with the same data. That's vital, okay? Why is that vital? More options, that's always good. Let's face it, you know, I'm not going to pick on Oracle, but Oracle's known for doing this with the price that they charge their enterprise customers. You know, Oracle has several different ERP applications, actually. So let's say that we're using Oracle. We start off down here, we're happy with this rate. Work up to here, get a little bit less comfortable. We get up to here, what should we do? Okay? You know? Think about this little stick figure here. All right? He should run away. Does everyone understand that? Okay? Rising costs like that are not good. Okay? Now, they're good if you're Oracle, but if we're not Oracle and we're trying to be as profitable as possible, this is not what we want. We want to have the flexibility, and that's what databases buy us. Okay? The data is not locked into a specific vendor. We could change SQL databases altogether if we wanted to. Okay? We own the data. It's stored in a way that we can import it into whatever database application we want to use. Is that pretty cool? I think that's insanely cool. All right? Because like I say, you don't ever want to have vendor lock-in with anything. All right, who disagrees? It's okay if you disagree. But that's my opinion. Okay, this is an opinion. But I think it's based on a lot of sound logic. Okay? Feel free to disagree, though. Anyway. So we want to remove information silos. Information silos are present whenever certain function units have access to information that other function units do not have access to. So for instance, what contrasts with an enterprise data warehouse is a data mart. Okay? So if you have a data mart, it can have the same exact information, but it's only accessible to a single functional unit. Now, when I say functional unit, what does that mean? What is a functional unit? It's a department. So accounting is an example of one. IT is an example of one. Finance is an example of one. It's a department. Okay, so if one department has access to a database that others don't, that creates an information silo. There's information asymmetry that results from that. All right, that's a bad thing in most cases, not every case. But the idea here is that we want people in the organization to have some access to the data, not necessarily complete access. So we can, of course, provide different authorizations to different users and different roles. So we talk in security. We talk about Rbac. What is Rbac? Exactly right. Role-based access control. We can apply that to this as well. Okay, so we create roles. You literally call it create role, and then you assign whatever privileges. So each of these are privileges. All right? So you have a read privilege. All right? If you have the privilege to read something, what does that mean? You can look at it. Okay? So in SQL, that probably is relating to select, right? Doesn't have to, but it most likely is. All right, insert. What does that mean in SQL? Add new records. Update. What does that do? Modifies stuff. All right, delete. What's that do? Removes records. All right, so all you're doing is, if you have a single user, use grant, and then say the username, and then whatever privileges you want to grant them. What's not up here is revoke. Okay, so you can revoke privileges as well as you can grant them. That's a good thing to do in some cases. But if you have a big company, let's say you have 10,000 employees, are you going to want to do that for individual users, or are you going to want to use roles and assign the users with whatever role is relevant to their position? Roles, exactly. So, just to wrap things up, we talked about joins, talked about views, talked about transaction, talked about integrity constraints, talked a little bit about indices, but like I say, we have 2 whole chapters dealing with them, so I had no point in talking about them all day. And then we also talked about authorization. Any questions? Yeah. Uh-huh. That's a very good question. It's going to go with from. So it comes immediately after from. Any other questions?